Hello and welcome back, and today we're back to working on the Bendix G15. If you're just joining us and you are unfamiliar with what the G15 is, this is a full-fledged vacuum tube computer from 1956. Although this one is serial number 238, so it's probably about 1958 or so. Still pre-1960s, all vacuum tube, all awesome. This particular one is on loan from Bob over at System Source Museum in Maryland, and if you haven't heard of System Source Museum, go check them out immediately. Bob has one of the greatest computing collections in the country. It is a stunning museum, and a lot of the machines actually work. He's got a functioning Xerox Alto that is on display. He has an Apple I with a replica next to it that you can use, and all sorts of other really amazing stuff, like a Wang calculator that is fully discrete. Absolutely stunning collection, but most importantly, all of the people that run it, they're all stunning as well. So go check out System Source Museum and give Bob and everybody there a high five for me. And in the meantime, I'm gonna get to work on this big guy. What we did in the previous episode was we actually did something amazing, and we flipped the big switch on the front here. We turned on the AC. Now this machine is a little interesting because you bring it up in stages. When you flip this big switch, the AC comes on. This powers up all of the filaments. It also powers up all of the cooling fans, and it gets the rotating drum memory spinning. And we confirmed that we have a good clock track and a good timing track coming off of the rotating drum. However, we did have a couple of problems. The bearings in the rotating drum are grumbly and noisy, and all of the fans are gross. These two spun up. The two on the other door initially didn't spin up, but they started to spin up and just sound terrible. And the large cooling fan here on the bottom for the drum didn't even try to spin. So what we're gonna do today is take all of those fans out, try to get them up and going and cleaned up and working perfectly, and then we're gonna pull the drum completely out of the machine and see if we can revive the bearings in it. So by the end of this episode, what I wanna be able to do is to flip this start switch here, have everything spin up and sound like it did in the 1950s. Smooth and clean and quiet. Quiet has as many air quotes as you can put around it. So we got a ton of work to do. Let's just hop right into it. First things first, let's get this big beast out into the middle of the room. Nothing quite like hefting around 1,000 pounds of computer before lunch. But to get access to the fans, I need to pull out the top row of cards. There are only 5 cards per row under the fan, and thankfully they're all keyed, so I don't need to worry about making note of card order. Now that I have space to work, I'll start by removing the 2 screws that go into the terminal block to bring AC to the fan. With those removed, I can pull the power wires fully out of the way and get to work removing the upper shroud. This is the large trim piece that encapsulates the fans and gives the door a nice Art Deco look. It's held in place with 13 screws all the way around the periphery, some of which are crammed into such tight spaces that I couldn't film and remove them at the same time. With all of the screws removed though, the shroud lifts straight up, giving excellent access to the fans, finally. The fans have a smaller duct that is held in place with 2 machine screws, and once that duct is out of the way, we can finally work on getting the fan itself out. There's a long crossbar that the fan motor bolts to, and then that crossbar is then bolted to the door frame with 2 screws. With the screws removed, finally the fan comes free and we can get it over and onto the bench. To get the fan apart, the first step is to remove the fan blade from the motor. It's held in place with a single set screw, but even loosening that up didn't do much. The steel motor shaft and aluminum fan blade had really kind of corroded into each other. The only way I could even get them to budge was wedging on them with a screwdriver. And eventually, after upgrading to a big boy screwdriver, I finally managed to get the fan to slip off. With the blades out of the way, we can now remove the crossbar mount. It's just 2 little screws and then it comes off easy peasy. Next, there are 4 long screws that go through the entire motor, holding it all together. And after getting those 4 fully removed, the end caps were actually still tightly in place. I had to take a screwdriver to pry them loose. But once they came loose, the entire motor assembly came completely apart, giving excellent access to the bearings. That all came apart really easily. It was maybe an hour's worth of work to get to this point. I only did one door for the time being. I'm gonna have to move over and get the other door later. But even the motor itself came apart. The serviceability on these is fantastic. Now, I could replace the bearings on this motor, but I'm a little nervous doing that because I need a puller to pull the bearings off of the shaft. The shaft is a press fit, and so in order to get those off, you have to get a very small puller onto there, and I could potentially damage the armature. I don't really know my motor terminology here, this piece that spins in the center. And the bearings don't feel that grumbly or bad. They're probably just a little dried out. So what I'm going to try and do first is work some oil into these bearings, and hopefully that'll get them up and going. But like I said, it was only about an hour's worth of work to get here. If this doesn't prove to solve our grumbly bearing issue, I'll order new bearings and pull it apart and actually replace them. But for the moment, I'm fairly certain that we can revive these bearings no problem. And so that's the next step. To re-lubricate these, I'm using a fine oiler tip combined with some non-detergent lubricating oil. The oiler tip is a little too small for this heavier oil though, but that's not necessarily a bad thing. I was able to finally dole out the exact amount of oil that I wanted, and then work the bearing back and forth to get the oil to wick into the inside. This should hopefully re-liquefy the grease inside the bearing and get it spinning nice and smooth. I've got it all back together. It cleaned up really nice and looks fantastic. The bearings feel extremely smooth, so working that oil in seemed to help a lot. I do want to give this a test before I put it back into the machine, and this is a 115 volt AC 1500 RPM fan. So do not do what I'm about to do. There is live mains AC floating around here that can absolutely mess you up. And the aluminum blade here is a finger chopper spinny blade of death. So I'm going to keep a nice distance, and I'm about as far away as the camera is actually. So I'm just going to flip the switch, see if it spins and pushes good air, and then we're going to flip it right back off. So here goes nothing. Yeah, wow. Okay, that spun up immediately. And the bearings have a really nice long spin time down. I'm gonna call that fan totally fixed. Now I just need to do this 3 more times. That's gonna be a lot of effort, but I think we can knock it out pretty quick today. With one door done, it was time to tackle the second door. This entire time lapse is a single unbroken take. I was hoping to demonstrate just how easy it is to get deep into the system to work on these things. Even though there aren't any visible screw heads on the front or sides of the machine, everything is still really easily accessible. And while we let this time lapse run, let's talk about cameras for a second. All of my time lapses are filmed with a GoPro Hero Session from 2015. It's a great little camera, and in typical GoPro fashion, it's tough as nails. And I always lean on the GoPro when filming in dangerous or tight places or doing time lapses like this. For all the other shots, I've been using a Canon EOS M. This is Canon's first mirrorless camera from 2012. I have a Viltrox adapter to use either a Canon 50mm prime lens or a 24mm prime lens. And all audio is recorded using a Sony ECM LV1 lapel mic and a Sony ICD PX333 voice recorder. And that's it. My entire setup is pretty simple and very cheap, but it produces results that I'm actually really happy with. All 4 door fans are reinstalled to the doors and powered up off of the computer. They seem to power up and spin totally fine. The oil really seemed to revive those bearings. But again, if they give us trouble in the future, we'll pull them back out. It's pretty easy to get to them. So we'll pull them back out and replace those bearings. But with those 4 door fans going, we need to work on the 5th fan, which is this blower fan right down here. And this one is extremely important. Initially, it looks like this is just a blower fan to cool the drum, but actually, once you get all of the panels onto this machine, the only place that air can be brought into the inside of the computer is through this opening here and this blower fan. So the blower fan is pulling cold air in from, well, down here because cold air falls, and it's filling the computer with this cool air. Now the 4 fans on the top of the doors pull that air up through these openings just underneath the vacuum tubes here, bring that air across and exhaust it out the top. So you're pulling cold air in from the bottom, filling the machine and exhausting it out of the top. It's a really cool design, but that means that this fan is absolutely vital. And when we powered it on in the previous episode, it didn't even try to spin. Now, it doesn't feel like it's super gummed up, so maybe we've got an electrical problem someplace else, but I am still gonna pull it out and clean it up and test it on the bench, make sure that it still spins up fine on the bench, and well, that'll tell us that if it doesn't spin up the next time we put power into it, we've got a problem somewhere else. So let's get to work getting this fan out. To get the main blower out, there are 4 screws holding the cage to the duct. They're a little fiddly with a non-captive nut on the backside, but using a flathead screwdriver and a tiny wrench, I was able to get these loose easy enough. Before we can remove the fan completely though, we need to remove the screws tying the power cord into the terminal block. And once those are removed, the blower motor and fan blade assembly pulls right out. Like the door fans, the first step is going to be getting the fan blades off. These are held on with 2 set screws, and with those loose, I'll actually give the exposed motor shaft a quick sand with some emery cloth. This makes it super easy to just slide the fan blades right up and off the motor shaft. Next, let's get the cage out of the way. The cage is bolted down to the 4 long machine screws that hold the entire motor assembly together. With that removed, next let's get the bearing caps off. These are held on with 3 tiny screws, then a little flathead can pop the covers right off, and this gives really good access to the bearings hiding out behind there. And initially I tried to wick some oil into the bearings through these openings, and this worked surprisingly well, but there's a more menacing problem lurking deep within. This is the power plug, and as you can see, the insulation has completely broken off the wires. That's a full 115 volt AC line voltage on those wires. So seeing the insulation flake away like that was a little worrisome. So I pulled out the X-Acto knife and sliced back some of the rubber sheath around the wires, and sure enough, the insulation is terrible all the way through. It's probably fine since the insulation can't go anywhere inside the sheath, but still it makes me really nervous. So to fix it, we need to get the motor completely apart. It's all press fit together, so initially I spread it open with a punch and hammer. Then I switched over to using a big screwdriver to get it the rest of the way. And because I'm terrible at this, I managed to get the motor apart completely off camera. But anyways, here's where things get difficult. The wire goes deep into the inside of the motor. So I need to get the top half of the casing off to give me the best access possible. And to do this, I just used a hammer handle in the middle and used the weight of the motor to work it loose. Then I peeled back and removed the sheath to expose the wires, and yeah, that's bad news bears. To fix this, I removed all the insulation, even deep into the motor, then ran new heat shrink insulation over the existing exposed wires. I actually ended up running double insulation on these just to be extra safe. And of course, I did a lot of ohming out to make sure that there weren't any shorts or they weren't touching each other. Then it was time to slip it all back together using the through bolts as a guide. And it's a little fiddly. All right, it's a lot fiddly, but I managed to get there in the end. Finally, I'll solder on new AC wiring to the stubs of existing wire. This way we have brand new wiring from the motor itself to the terminal block. And with everything back together, let's give it a quick test. I'll just flip the switch and that's excellent. No fire and brimstone, just nice and quiet with a lot of airflow. Absolutely perfect. All the cooling fans are back in the machine, and we have confirmed on the bench that all 5 of them are working. They sound really good and move a lot of air. So the next time that we flip the big switch on, if one of them doesn't spin up, we know that it's not a problem with the fan, it's a problem with something else inside of the Bendix, and that's going to require deeper, harder troubleshooting. But the next step before we flip that switch to confirm those fans, I want to get the rotating drum memory out. Because when you flip that switch, not only do all the fans come on, but the rotating drum starts spinning as well. And as we heard in the previous episode, some of the bearings in there are not happy. They do get happy. They'll be super quiet for 5 minutes, and then they'll be grumbly for 5 minutes, and they kind of move back and forth as the grease inside the bearings moves around. So I want to pull this thing out, get it up on the bench, and see if we can revive the bearings. Now, I do not want to replace the bearings. And the reason for this is because I think as soon as we remove the bearings, we lose alignment on everything. So that side-to-side horizontal alignment, if it's out just 1/1000th of an inch, we will no longer be reading our clock track correctly, and we'll no longer be reading our timing track correctly. Now in the field, this is not a problem because the field engineers would just write down new clock tracks and new timing tracks, but we don't have any of the tooling to do that. So we want to revive the bearings as best as we can in situ. And I think the method that we were using on the fans will work here. But in order to do that, we got to get the drum out. So I'm going to pull out the wrenches and just get to work. Getting the drum out is one of those things that seems like it would be a nightmare, but it's actually surprisingly easy. It's just 4 bolts and a rubber coupler, and that's it. With everything loose, the drum pulls right out the side of the machine with ease. It didn't even take me a full tool song to get this drum out and onto the floor. Finally, now that we have the drum on the bench, to get access to the bearings, let's remove this plate. It's just 4 Allen head bolts, and then away it comes. Looking closer at the bearing here, we can see it just behind the retaining clip right here. It's all the way back here, and this is the metal shield that kind of seals it up and keeps all the grease and whatnot inside. And getting to that is not easy, but because I can actually just straight access it from here, I can use this pick that I've been pointing with and just punch a hole in it, and then I can get my oiler in there and put some oil in the bearings and then work it around slowly. So that's the current goal, is to just take this pick just like that. We'll do it live on camera here. Take a little hammer and give it a little tappy tap. There we go. I think that's a better angle. You guys can maybe see a little more clearly what's going on here, but we'll just take our oiler here, pop it in the hole, and just squeeze in a little bit of oil. We'll squeeze in just a little bit and then rotate this 1/4 of a turn till we get to the next cutout here, and squeeze in a little bit more. And we'll just keep doing this, squeeze in a bit, rotate, squeeze in more, and we'll just keep doing this over and over and over again until I don't know, it feels about right. There's a lot of working on intuition here. But we'll just keep doing that, and hopefully that fixes our bearings up nice and easy. And when we're done, we'll take just a little bit of silicone sealant or something and plug the hole right here, so that way dust and other stuff doesn't get in while the drum is running. All right, everything is plugged back in, and I wish I could explain to you guys. I can hear my heartbeat. That's how exciting it is to flip this big switch every time. I've only flipped this switch, I think 4 or 5 times. In the previous episode, we flipped it twice for the primary filming, and I had to flip it a few more times for getting B-roll. So this is still a very rare and exciting opportunity to be able to flip this switch. But what we're expecting to see is all 5 fans spin up and the drum to spin up, and hopefully everything sounds smooth and quiet. Now we will hear some clicking as the sequencer goes off and does its thing, but well, here goes nothing. Let's hope everything works. All 4 fans came on up top. I can definitely hear them. The primary blower fan is on. I can still hear something out of the drum. There goes one click. There goes our second click. That means AC is now fully up. We can bring this right up to 100%. There we go, we got our AC light on. There should be one more third click that will essentially tell it that it's ready for DC to turn on. There goes the third click. Okay, so everything's still working. The drum is still a little noisy. I can definitely hear it. I don't know if it's coming from the drum or if it's coming from the electric motor. I did oil the electric motor, but it's certainly quieter than it was, so it still could be either. That's definitely going to require a little more listening around and seeing if we can hear where it comes from. Almost immediately after I turned the camera off in that previous shot, the drum got quiet and has stayed quiet ever since. It's been about 10 to 15 minutes, and it's just spinning along, humming along perfectly. So it probably just took a little bit for all of that oil that I put into the bearing to break up the original grease that was in there and re-liquefy it and move it all around. And I think we're going to be good for moving forward on this build with those bearings in there like they are, which is excellent news. It means we didn't have to take the drum completely apart. So we are a go for starting to work on bringing the DC up. In order to do that, all I really have to do is push this little reset button here, but that's a bad idea. There's lots of lockouts and other things that aren't ready. Most notably, the paper tape mechanism up here is in kind of rough shape. So we need to go ahead and pull this all the way out and put it on the bench and start working on bringing it back to life. There's also some capacitors that we need to take a look at and the typewriter. So we got a lot ahead of us, but man, it feels really good to have the machine working essentially perfectly. Right now, the drum is spinning and all 5 cooling fans are spinning and moving good air, and I don't have to yell to talk over it. I mean, I am yelling because I'm so freaking excited, but I don't have to yell. It sounds like I imagine it sounded when it was new in the 1950s, and being able to sit here and experience that is amazing. So, Bob, thank you so much for giving me this opportunity. I am absolutely going to keep plugging away at this thing, and I fully expect us to have DC up and executing code before the end of the year. So, we got a lot of work ahead of us, and I think it's going to be kind of hot, sweaty work, because you may notice this is the first time in the episode I haven't had a jacket on, and that's because this thing is pumping out heat at a prodigious rate. The temperature in the room is rising rapidly, but it's absolutely worth it. So I want to thank you all so much for watching, and I hope to see you in the next episode.